Well, hello again everybody. Today I went to an auto jumble swap meet, and that was being held at the Magna Centre, which is in Sheffield. It's on the site of an old furnace or smelting works, something like that, steel works anyway. Quite an interesting day out if you're ever passing Sheffield. Well, I think it's about time to slap my junk on the table, isn't it? Well, this is the first item that I bought, and I can't really tell you anything about it, and the fact the guy that was selling it didn't know anything about it either. It's some kind of Mercury Switch, because it's got another vial of mercury inside here, and that vial of mercury slops around inside, and it's got two contacts here, so we'll connect the flute meter up to that in a minute. So I'm not exactly sure what this is. I'm trying to figure out how it would have operated. I'm kind of wondering if this could have been some kind of either thermostat vessel or maybe some kind of pressure activated switch, something like that. I'm kind of thinking that there might be some high temperature involved, because you can see that the leads that are connected to this little vial of mercury here have got these little porcelain insulators on them. So normally they fit that kind of thing for a high temperature application. As I said, at this end we've got like a stem, like a stem valve or something. And if we press that, if I press against that, I can feel there's quite a lot of resistance. I think there must be a spring inside there, which is pushing this little tit out against my thumb. And I wouldn't be surprised if this was something that would maybe have maybe a metal disc and then maybe a diaphragm pressing against it. So I'm going to go for a pressure transducer. I'm just having a look around it now to see if there's any maker's marks on it. And no, there isn't. No maker's marks at all. So as I said, it appears that the mechanism pivots round. So I wonder if I press this thing up, press this stud up, if it's going to make this vial of mercury tilt, which it obviously, yeah, it tries to. And there is also on the top here, there's obviously an adjustment screw there. So this little adjustment grub screw here, that sits down on the top of the this brass rod, this spring-loaded rod that runs through the whole assembly. So you can see that this must, when it's sat there, it just sets where this mercury vial kind of sits. It causes it to sit in a certain position and kind of preloads it. So I'm guessing what you would do is you'd adjust this grub screw so that the mercury starts to tilt, maybe like that, and then when this brass rod pushes up, it maybe just pushes it that little bit extra and makes the thing activate. And I'm also guessing that there should have been a cover around this, which we're missing. So I'll just let you have a look at it and see what you think. So here's a little brass, yeah, I got a little brass tit, didn't I? So this is obviously designed to press against something here. Not sure if that would unscrew. There's the adjustment grub screw there, and you can hopefully see where it sits on the top of the brass rod that goes all the way through the body. And you can see these little ceramic wire covers. So I can't really tell you much more about that, because I don't know, there's no maker's information on it. I suspect that this should have had some form of cover around it, because just unscrewing this here, yeah, I'm sure that's what would have done. There would have been like a cylindrical cover that would have gone over this, like a cup, and I'm sure that screwing that down onto the top of here would have retained the cup. I wonder if I can activate it also by pressing this. Ooh. I wonder if I can also activate it by they're always falling off these clips. Now I'm wondering if I can also cause it to be activated. Okay, so I've actually... So you can see the Mercury's at one side here, it's at the right hand side, and the actual two contact electrodes, you can see them, they just stick down out of the bottom of the tube. So if I just tilt this by hand, the Mercury runs across and it shorts out the contacts. Well, I'm just going to try and press the little activation button on the bottom of it. I don't know if I'll be able to do it because it's got a really hard spring on it. No, that's quite actually hard to do. So I wonder if I can just adjust the little adjustment screw on here. That might make it a bit easier to operate. Let's have a go at that. Probably find out that this whole assembly's probably come from a nuclear power station. It's probably hot with radiation or something. Well, that reminds me of a little bit of a story. Last year I found myself in a scrapyard, but it was a great big industrial scrapyard, and it had a rail link, this scrapyard. Most of the scrap didn't come in by road, it came on the back of trains, because railway signalling and depots, and that's one of the things that I kind of play with for work. So yeah, I was at this scrapyard depot, if you like, and it wasn't too far from where I'm based in the UK, and I noticed what I thought was cameras, and these cameras were kind of pointing at the track where the vehicle would actually enter the scrapyard. They had what looked like an array of cameras that would kind of surrounding the rail car as vehicles came in, and I was looking at them, and then these cameras, you know, they didn't have lenses on. They had kind of, well, flat metal fronts on them, and I thought, oh, that's a little bit odd. And I was staring at these and you know, trying to work out what these things were. And initially what I thought they were was maybe something just to automatically detect the gauge of the vehicle, because, you know, you wouldn't want a train to go out of the depot where it had a big piece of iron sticking out the side, because it would probably hit the side of a bridge, or you know, a passenger stood on a platform, or maybe another train. So when I first looked at it, I thought that this you know, these camera systems were some kind of gauge loading equipment, you know, to set an alarm off if the load was too wide, if it was out of gauge, as they say. Kinematic envelopes and all that good stuff. Anyway, so I was looking at these cameras, and yeah, I was a little bit intrigued. So I went and asked what these things were, one of the chaps who was working there, and he explained that they weren't actually cameras. What these things were was radiation meters, Geiger counters, because I don't know if it happened in the UK or some other part of Europe. They found that some people working in a scrapyard were either very badly injured or maybe even killed, because they'd bought a load of scrap metal that had come from, you know, Russia as it collapsed, and you know, for all we know, this scrap metal came from Chernobyl or somewhere like that, somewhere it shouldn't have come from, and it was you know, it was very radioactive, and I think some people had, you know, picked up some of these lumps of interesting metal and taken them home, and then some days later all died of horrible radiation poisoning. So it appears that it's quite common now for you know, people who deal in this industrial scrap and large quantities of waste, you know, have these Geiger counters installed at various locations to deal with this potential issue of contaminated metal. So yeah, so who knows what this was monitoring? Maybe it was monitoring a power station full of radiation, or, knowing my luck, perhaps it was you know, monitoring the temperature of a large vessel of anthrax, or yeah, something equally good fun. Anyway, let's adjust that down a little bit. I don't actually think this is designed to be adjusted fully down because it's pretty much at the end of its travel now, and it's still not as far down as I would like it. That'll do. Yeah, that seems to be working a bit better now. Yeah, certainly quite a powerful spring pushing it back against me there. So, I'm interested to know what this is. Has anybody seen one of these before? Is it part of is it a temperature sensor, or is it some form of pressure transducer? I think I'm probably going for pressure transducer, but I don't know. I suppose it could also be an end of travel limit switch of some type, but no, I'm definitely I'm going for my money's with pressure transducer. And we're just seeing part of it here. This has obviously been removed from some other mechanism. And of course, like most of my little possessions, I've got absolutely no idea what to do with this. I just bought it because it was interesting, and the Mercury was just very pretty. And yeah, given how outlawed it is, you know, Mercury seems to be a health and safety nightmare these days. I mean, if you believe all the publicity, just being in the same room as Mercury will drastically reduce your life. Yeah, don't drink it. Well, if this much mercury bothers you, wait till you see what I've got next. Well, I don't know if any of you can see what this is, but basically, it's kind of like it's a car shape. It's a glass bottle in the shape of a car. I don't know what it originally contained. Again, it has no labels on it. There's nothing on the cap, but it weighs an absolute ton. It's really heavy. I mean, like ridiculously heavy. Sometimes, you know, you pick things up and the weight feels wrong because as human beings, you know, we all kind of look at objects and based on our experience, you know, you kind of estimate what things weigh, what the mass of something is. And you know, when I saw this, I wasn't exactly sure what it was at first, so I just picked it up off a stall and immediately thought, oh, that's bizarre. And I thought, oh, it's a little model of a car, and it's either painted silver inside or and then, you know, it was heavy. And then I thought, oh, it's been you know, somebody's poured lead into it. And then I actually noticed that the lead was moving. So what this is basically, it's a bottle full of mercury. I'm not going to open this bottle up today. I mean, it's literally, it's almost an accident waiting to happen. You can't believe that the general public and everybody was handling this thing and throwing it around. And yeah, well, I decided for health and safety reasons that it had better come home with me, because it was obviously a danger to the greater public, as it were. And yeah, I paid £10 for this. I mean, the guy was trying to sell me what a lovely model of a car was, and I was just interested that it was full of mercury, because it's very, very heavy. So I'm not really going to do much more with this today, because I don't know if it's just because the mercury is in this glass bottle, but it looks kind of really a little bit dirty and manky. I mean, can mercury get dirty? I'm going to have to do some looking this up. But I wouldn't be surprised if I can ask, I bet Simon Spears knows all about this, because I think he collects and restores barometers, and I bet he's got some little bottles of mercury squirreled away somewhere. So it does look a bit kind of grubby inside. Let me bring you in, maybe you can see a little bit. So you can see that I just thought it was like a silver painted car from a distance, but no, I promise you it is full of mercury, and it's very heavy. And obviously this was probably some form of whiskey bottle or something, and probably all quite toxic. But yeah, I mean, this is the kind of substance that's totally banned now, and I'm sure it is quite dangerous in the wrong hands, but I think I'm probably pretty much sensible enough to own it without killing myself. And obviously when it comes to disposing of it, I'll obviously be very careful how I dispose of this. I'll I'll wait till there's nobody around before I pour it down the drain. On a more serious note, the reason I've actually bought this is because I am quite interested in making scientific equipment. As some as you know, I've got a lathe and milling machines and stuff like that, because I quite enjoy doing making instrumentation. And you know, there's lots of things you can do with mercury. It has lots of interesting electrical effects, on top of the fact that and the way it expands under temperature, and the way that it's, you know, it is a liquid metal. It's a very interesting substance. So maybe in the future we'll have to do something with this. But I think in the first case, what we'll do, not today, in another video, I'm going to tip this mercury out, and we'll actually have a look at it, see if it is clean or if it looks contaminated. And if mercury is contaminated, if it is dirty, is there a way of cleaning it? I'm kind of looking at it, and wherever there's like an air pocket, the surface of the mercury looks kind of just dirty, as though it's got, well, dirt in it. And I'm guessing this is a lot like the effect where, because the mercury is so dense, you probably get particles of dirt and rubbish and crud, if you like. I suspect it floats to the top, you know, like liquid metal in a crucible, and you scrape the slag off the top. So I'm suspecting what we're kind of seeing is, like, I don't know, would it be mercury oxide or mercury oxide, maybe, I'm not exactly sure, and just a variety of crap and crud that's floating around on top of it. So we could do with pouring this into something and then skimming off the crud. And the other thing I want to do, I don't think it's a good idea to keep something like this in a glass bottle. We need to purchase some safe container to put this in. So that's what I'll be doing, and we'll look at that again in the future. And item 3, and yeah, £20, and this is a well, it's a digital micrometer. Now, I've actually got a huge pile of, you know, the traditional micrometers, but you know, it's that thing, you get a little bit older, don't you, and it's very easy to misread a micrometer, even though I am experienced at reading them. You know, they're getting harder to read as I get older, and it's very easy to make a mistake reading a micrometer. It's incredibly easy. I'm sure machinists who have been doing it 20 years probably hardly look at the dial. They probably count the rotations and things. But if you have a look at a micrometer, in fact, let me just bring you in. I'm hoping that's focusing. Basically, you can see there's a little graticule on here, and it's actually quite easy to be kind of I guess it's being half a turn out the way you actually read one of these. I mean, I must have made that mistake literally hundreds of times. You really have to take your time, take a lot of care when you're reading a micrometer, because normally you've got basically 2 scales on here. You've got kind of your first number on there, and then the second part of number is read off from where the line intersects with the rotary part of the dial. I'm not going to explain how a micrometer works. I'm sure most of you people who are using this, but you'll understand it's easy to misread it. So because of that, well, actually it's not because of that, it's because it's cheap. That's why I bought it. I thought £20 was quite cheap. I mean, I'm sure that you can buy these things now from China very cheaply, but I think Kennedy is a well-known, I think that's a fairly respected brand. It seems to work. I mean, basically, that I say it works. It's not really a lot to go wrong with one of these. I can't feel any wear in it. The anvils close up beautifully. You can almost feel whenever you close the anvils on a micrometer, as the anvils come together. I don't know if I'll be able to focus that. As these anvils come together, you get some stiction occurring. And there's actually a lot of argument about what causes that. You know, it's something which isn't clearly understood. A lot of people, the old boys, would have told you can do this with, I think they would call it slip gauge blocks. If you get two slip gauge blocks and put them together, or ring them together as they would call it, you would find that the slip gauge blocks are kind of blocks of steel, and you use them to build up any height you want and then check your test instrument against them. So this would be a slip gauge block, and maybe that would be 1 centimetre high, and then you'd have another one that was maybe 2 centimetres high, and you put these together. But the way you actually use slip gauge blocks, they call it ringing them together. So what you have to do is you kind of slide them in and twist them like that. But you find when you ring them together, if you actually let them go, they'll be stuck to each other. You know, you can't separate them. Now, a lot of the old boys would have said that the reason you can't get them apart is because the two surfaces are so finely ground that they come together perfectly and they create a vacuum, and it's actually the air pressure that holds the slip gauges together. But there's been some quite interesting experiments done, and I think a chap on YouTube is called Cody, and he has a channel called Cody's Lab, which is fascinating. So again, stop watching my videos and go and watch Cody's Lab. And he's done some experiments where he's taken slip gauges and he's put them in a vacuum chamber. Now, if it was the air pressure holding them together, the slip gauges, the slip block should just fall apart. But he's found that the slip gauges do stay stuck together. So it's not an atmospheric effect, it's not a vacuum. And what people are actually saying is that, I don't know, I'm not a physicist, but they're saying there's some nuclear force involved. It's actually the the atoms of metal reaching out and grabbing each other. So there's some some nuclear science perhaps involved. So what I was basically saying is, when you close these anvils together, what I find that when I actually open them up again, there's just a little bit of a resistance, and then they break, and that's this stiction that we're overcoming. So it works quite nicely, this. You'll find that all micrometers, they have a clutch mechanism on them, because you don't want to rive on this. A lot of people treat these things like G-clamps. So there is a clutch on here which will, can you hear that? Just bring that here to the microphone. So you close these anvils up, and then as they come together, it slips. And again, the old guys, the machinists, they won't sit there doing that. You don't need to do that. It's just so you always have the same amount of closing force, because you could really rag these things round. If you grab this bit, you could twist it really hard, and you could probably change the reading on it by forcing it. In fact, I can do that. That's where it wants to be, but if I try and force that, I can get it to go a little bit further. But yeah, I'm not going to force it. Shouldn't do that. So yeah, basically you turn this and it's got a digital display on it, which makes it much easier to display. So basically it's got a digital display on it, which makes it very much more easy for me to read. We can convert from inches to millimeters, which is nice. You can hold readings, and you can also zero it, and it's got an origin control. So I'm not exactly sure how, I haven't figured out exactly how it works yet, but the zero and absolute, that's basically so you can actually take an absolute reading, or you can do an incremental. Now, incremental readings are done if you want to compare one object to another. So you will it's like the tare weight on a scale, where you don't want the weight of the crate of the oranges, so you put the crate on first and you press tare. Well, the incremental control is very much the same on a digital micrometer. So I wonder if I can do that. I'm getting little objects. Right, okay, let's put a 2p in. So that's giving a reading of 1.8 millimeters. And again, I'm not exactly sure how I would press this. I'll try doing the zero control. So that's zeroed it out now. But we've still got the 2 pence in there. So if I was actually to put, I don't know, I'm going to just measure a different part of the 2 pence. I'm going to try and catch it right on the lip. Right, and the right on the lip, it's actually a bit bigger. It's 0.059 millimeters bigger than it was in the center. So yeah, that's what you can do relative and absolute measurements, and that's quite handy. Not something you can do so easily with a traditional micrometer, where you've got to remember the readings in your head and then take one from the other or add them together. So yeah, quite pleased with that. I think it was okay for £20. It feels a little bit grubby. I'm not sure what the quality of this thing is, but it seems in good condition to me. It just needs a bit of a clean, and that will be fine. So we've also got another little wheel on here, and what that's for, basically you can just lock this off so it won't turn. What I would say, if you're looking to buy any kind of measuring equipment, you really want to have a good look at the physical condition of it. If it looks as though it's been, I don't know, a bit mangled, if it's not in pristine condition, just walk away, because equipment like this is basically just so easily damaged by abuse. I'm just opening it up here so I can just do a visual inspection on these anvils. And I'm looking at them. I don't know if you'll be able to see them on the camera. Basically, they are very brightly polished mirrors. Usually the very tips of these are hard, and in fact I can see the way that the hardened material's been sintered onto the ends of them. So it's obviously a composite shaft with some very hard material put on the ends so it doesn't wear. But these are mirror finishes. They look as though they've never been used, because if they had been used, they would have at least some little tiny scratches on them. So they've either not been used at all, or they've been used for measuring very soft things. So let me just bring you in so you can hopefully see the display a little bit better. I think what you've got inside here is some form of rotary shaft encoder, and then basically it just counts the rotations very precisely and displays them. And I just actually closed the anvils up there just to touch them together, and I said I could feel the stiction earlier. Again, that's not a good idea. You really don't want to leave the anvils touching each other. I mean, it's worth doing it just to check the things, and I've just re-zeroed it there. But you must never leave them closed up like that, because again, those surfaces are so finely polished and so clean, they will actually cold weld together, and as you actually undo them, you will rip metal from one face to the other, and yeah, you'll roughen them up, which I'm not going to say it'll ruin them, but you know, this is precision equipment. You need to take care of it. Okay, what have we got next? Well, we've got a DTI, or a dial test indicator. And another. And another. Ooh. And another. And another. Oh, and another one. Oh, and guess what? Oh, another one. And more. And finally, that one. Well, to be honest, this is one of the things where my eyes were bigger than my belly. These are made by Batty. I've not heard of that name before, so I don't know if they're actually any good or not. Maybe we should look that up. They make Batty. I think most of them are made by this company. This one says Verdict, England. What have we got? We've got Batty. Batty. Quite a lot of these are Batty. Verdict. Batty. Verdict. Mitoyo, which is a very good Japanese make. Another Verdict. Another one that says Verdict on them. Batty. 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 Verdict. Okay, so we've got quite a collection from Batty, and quite a few from Verdict, and one Mitoyo. So we've got two types here. You've got the type with a plunger on it, like here, and it says that this one is basically got a basic resolution of 0.01 millimeter. Yeah, 0.01 millimeter. So I'm guessing that each one of these divisions on here is 0.01 millimeter. Unfortunately, I haven't got a stand to double check these on or anything at the moment. And well, I can tell you a little bit about buying these. As he said, as the knob just fell off, just come unscrewed, that's all. Basically, again, why did I, okay, so why did I buy all these? Well, the reason I bought them all is because they were at such a cheap price. It was kind of pretty much £10 for a big box full of the ones, and I think before me a lot of people have been in and got the good ones, and some of these are a little bit damaged and jumped on and scratched, and I think the bloke who was selling them just wanted to get rid of them, because he had literally boxes and boxes of them. He had hundreds of them, maybe even thousands, but hundreds of them. All come out some factory somewhere. So I bought them because they're too good a price to miss. Now, what do I use them for? Well, as I said before, I've got a lathe, and probably the most common thing, the most common reason for using one of these is, depending on the type of chuck that you use on the lathe, some chucks are self-centering, but if you're using what they would call a four-jaw chuck, you actually have to centre the workpiece in the lathe yourself. So what you actually do is, if this is the piece of rod that you want to turn in the lathe, you actually just press the DTI against it, and then if it's out of round, what you will find is it will, as you rotate the lathe round, the chuck round, and you don't do this under power, you don't start the lathe, you just run the chuck round by hand, you will see this needle running round like that. Now, if you've got the piece of bar perfectly centred in the chuck of your lathe, you'll find that you will be able to turn this and this needle will barely move. But when you first try it, you'll find out that you haven't got it right, and this thing will bounce around quite a lot. Now, this one is quite a good one for using in a lathe because it's got a long travel. You can see it's got two dials. Some of these have only got a single dial. Let's find a single dial one. Right, that's a single dial, and basically the slightest little touch on that causes it to spin round multiple times, and it's okay, it does go round multiple times, but you don't necessarily know how many times it's gone round, whereas this one has got the second indicator dial on it, so yeah, it does go round more than once. Now, it looks like this thing isn't quite zeroing perfectly, and to be honest, they never do. I think a lot of these, they're obviously old, they've come off machines. I don't exactly know, well, I don't know where they've come from or exactly what they were being used in, but usually they get dirty inside. You get dirt and crud in here, and you also get people lubricating them, and the favourite thing that goes wrong with them is people use oil in here, which is just too heavy. You know, it'll be a little bit stiff, so what they do is they think they'll lubricate it to help it, and I'm pushing this in, and the action is a little bit damped. It's not sticking, but it almost wants to stick, and I can feel my hands are a little bit gritty and dirty, so really these want pulling in bits and they want cleaning. Now, I'm not exactly sure what you would use to clean these. I'm kind of thinking that probably you would clean them out inside with something like IPA, just something to clean away all the dirt and the crud, and then maybe you use a very, very light oil, or maybe you don't even oil them at all, because quite a lot of mechanisms are so finely balanced, the last thing you want to do is gum them up with oil. But certainly if you do put a lubricant in them, I'm sure it must be a very light lubricant. So I bought a job lot of them. I thought some of them are going to be good. I did make a point of trying to go through them and sort out the good ones from the bad ones, and you know, hopefully I've got some winners here. A lot of them have got scratch dials on them, so I actually thought that would be interesting as well, to try different methods to try to repolish the plastic on the dial. I know a lot of people have said you can use various abrasive stuff and toothpaste, and then you can use Brasso. So I thought, again, that could be quite good fun, because I actually quite enjoy doing these kind of non-taxing kind of little experimental jobs. So I didn't pay much for these. I'm kind of hoping that if I can get them all going, get them cleaned up, I can sell some of them myself or give them to my friends who are interested in machining. You can't have too many of these. So as I said, there's two types here. I'm not exactly sure what the two names are, but this one has basically got a rod that pushes in and out. But this is a slightly different type in that the rod on this one basically sticks out sideways like that, and you actually push it up or down like that. Is that going to focus? So I just touch that rod. I mean, it's a very, very delicate movement, that. So where you would use this type is, imagine you've got a milling machine and you put a block of metal on it, because we're going to do some machining on the metal, and now the bed in the milling machine is going to move left or right like that, and it also moves in and out, but you're probably going to do your cutting from left to right. So what you want to do is you want to make sure that the edges on your piece of metal are parallel with the cutter. So what you would do is you hold this in the like the headstock or the tool holder of your milling machine, being very careful not to start the machine up, and you would you would just touch it against the edge of the workpiece like that, and then you would crank the hand wheel and move this along. And what you'll find is if it isn't dead parallel, this will, well, basically it'll tell you how parallel it is. So you'll basically undo the clamps holding this thing down. You'll give it a bit of a tap with your hammer, straighten it up, and then you'll run it along again. And basically you can set up your workpiece very accurate with your tooling. So that's the sort of place where you would use this. Now the other area you might use this type of DTI is if you've got again something in the lathe and you're looking for an internal bore. If you're doing some boring, and you might want to again set the chuck up on the lathe to give you a concentric bore. So what you would do is you would actually, again, you would put this in the tool holder of your lathe, and then you would just put that into the bore like that, and then you would adjust the chuck to line up the workpiece, and you'd slowly rotate the chuck on the lathe, and hopefully this needle wouldn't move at all if you've got it registered perfectly, but chances are it will be slightly out of adjustment, so you'll then have to go and